In the third part of section 1.6, we will talk about the signs of trig functions in different quadrants, whether a trig function is positive or negative. Now, let's start with labeling the quadrants. The coordinate plane is split into four quadrants labeled in counterclockwise direction, 1, 2, 3, 4, as you can see. In the first quadrant, the x and y values are both positive. The x is positive and the y is positive. Therefore, all three functions, sine, cosine, tangent, and their reciprocals are positive. Now in quadrant 2, let's take a look at what happens. But before that, remember that the sine is associated with the y value, the cosine is associated with the x value, and the tangent is y over x. So let's take a look at what happens in the second quadrant. In quadrant 2, the y value is positive and the x value is negative. So because we have a positive y value, the sine and cosecant are going to be positive, which means the cosine is associated with the x value, so the cosine will be negative. And the tangent is y over x. Well, in the second quadrant, the y is positive and the x is negative. So if you have positive divided by negative, then the tangent will also be negative. And we can see here in quadrant 2, the sine and cosecant are positive, the cosine and the tangent are negative. Let's take a look at the third quadrant. In the third quadrant, the x values are negative and the y values are also negative. So we have a negative x and a negative y. Sine is associated with the y value because the y value is negative. The sine in quadrant 3 will be negative. The cosine is associated with the x value because the x here is negative, the cosine is also negative. However, the tangent is y over x. So if you have a negative divided by negative, it's going to be positive. So in quadrant 3, the tangent is positive and the other two functions are negative. In quadrant 4, the x's are positive and the y's are negative. So sine is associated with the y value. Because sine is associated with the y value and the y value is negative, the sine will be negative. The cosine is associated with the x value, and since the cosine is positive, and since the x is positive, cosine will be positive in quadrant 4, and tangent is y over x, so negative divided by positive will be a negative. Now, the easy way to remember this is all students take calculus. All students take calculus. If you don't like that one, you can make up your own. All students take calculus. So in quadrant 1, all the functions are positive. The S just tells you which function is positive in quadrant 2. So in quadrant 2, the sine function is positive because the y's are positive. And the other two are going to be negative. So whatever function is positive, the other two are negative. So sine's positive, cosine, tangent are negative. In quadrant 3, it's all students take calculus. So quadrant 3, tangent's positive, which means sine and cosine are negative. And in quadrant 4, cosine's positive, which means the other two, sine and tangent, are negative. So let's take a look at some examples. Determine in which quadrant the terminal side of angle theta lies. So we're given that sine is positive and tangent's negative. Now we have all students take calculus. We're going to use the sine being positive to narrow it down to two quadrants. So we have to ask ourselves, where is sine positive? Well, sine is positive in quadrant 1 because everything is positive, in quadrant 2. Okay, so here we narrow it down to quadrants 1 and 2. But then tangent is negative. In the first quadrant, tangent is positive, so it can't be this one, which means the correct quadrant is going to be quadrant 2. Part B, tangent is less than 0, tangent is negative. So we have all students take calculus. Well, first off, we're going to start with the fact that the tangent is negative. Can't be in quadrant 1 because there the tangent's positive. Can't be in quadrant 3 because that's where the tangent's positive. So you got to think about where is it negative? And it's negative in quadrants 2 and 4. And it also says sine is less than 0, which means sine is negative. So it can't be quadrant 2 because in quadrant 2 the sine is positive, which means it must be quadrant 4. Okay, so start with the first one. Tangent is less than 0. Where is tangent less than 0? Can't be in 1 or 3, that's where it's positive, so it has to either be in 2 or it has to be in 4. So narrow it down by 2, and then use the second one to narrow it down to 1. The next one says cosine is greater than 0, so we have all students take calculus. Where is cosine greater than 0? Cosine is greater than 0 in the fourth quadrant, also in the first quadrant. So we have our two options that are 1 and 4. Now, out of these two quadrants, 1 and 4, where is sine negative? Where is sine less than 0? Well, I know in the first quadrant, sine's positive, so that can't be it, which means our correct answer is going to be quadrant 4. Here, tangent is negative 3/4. So negative 3/4, it just means that the tangent is negative. So we have all students take calculus. I know that in quadrant 1 and quadrant 3, the tangent is positive. So then you got to think about, well, where is it negative? It's going to be negative in quadrant 2 and quadrant 4. Out of those, the second restriction says the cosine is less than 0. I know that in quadrant 4, cosine is positive, so it can't be that, which means the correct quadrant is going to be quadrant 2. Sine is negative. We have all students take calculus. So if sine is negative, can't be 1, can't be 2. That's where sine is positive. Has to be 3 or 4. Cosine's negative. Well, I know in quadrant 4 cosine's positive. That can't be it. So the correct answer is going to be quadrant 3. And then lastly, cosine is greater than 0. So we have all students take calculus. Where is cosine greater than 0? It's greater than 0 in quadrant 1 and also in quadrant 4. And sine is 1/2. So 1/2, it means that the sine is positive. Can't be quadrant 4 because in quadrant 4 only cosine is positive, which means sine is negative. So it has to be quadrant 1. Okay, think of questions to ask in class about these. The next problem says if sine is 3/4, so what we know here is that sine is positive. If sine is positive, that means we can either be in quadrant 1 or quadrant 2. It's all students take calculus. This is quadrant 3, this is quadrant 4. Now sine's positive, so it has to either be quadrant 1 or quadrant 2 because that's where sine's positive. That's where the y's are positive. But cosine is less than 0, so it can't be quadrant 1 because I know in quadrant 1 cosine is greater than 0. Cosine is positive. So here sine is positive and cosine is negative in quadrant 2. Now here's what we have to do. It says sine of theta is 3/4. So we have some angle theta, and the sine of that angle is 3/4. So for theta, the opposite is 3 and the hypotenuse is 4 because remember, according to SOHCAHTOA, sine is opposite over hypotenuse, right? So opposite is 3, hypotenuse is 4. So what we're going to do is we're going to draw an angle theta, this angle here, in quadrant 2. Why is it quadrant 2? Because this is where sine is positive and cosine is negative. And for this angle theta, we know that the sine, the opposite over hypotenuse, is 3/4. Okay, so sketch the right triangle in the appropriate quadrant. In this case, appropriate quadrant is quadrant 2. Second step, fill in the ratios and solve for the missing side. So this side is missing, the x is missing. So what I'm going to do is I'm going to use the Pythagorean theorem. I'm going to say x squared plus 3 squared equals to 4 squared. So this is x squared plus 9 equals to 16, which means x squared is 7 and x is radical 7. Remember, we get a plus or minus for anytime you square root a variable, you always get a plus or minus, but we keep the positive value because x is distance. However, having said that, because x is going in the negative direction, this is actually going to be negative radical 7 because we're going in the negative direction. So x is going to be negative radical 7. Okay, now it says, we know what the sine is. It's opposite over hypotenuse. It says find cos theta. So cos theta is going to be adjacent over hypotenuse, which is negative rad 7 over 4. Next one is tangent theta. Tangent is opposite over adjacent. So for angle theta, opposite is 3. The adjacent is negative radical 7. If we rationalize, we multiply top and bottom by radical 7, and we get the negative moves to the middle. So it's going to be negative 3 radical 7 over 7. That'll be your tangent. And then it says find the cosecant. So cosecant of theta is a reciprocal of sine. If sine is 3/4, then the cosecant is going to be the reciprocal, which is 4/3. Then it says find the secant of theta. Now remember, when you take a reciprocal, never take the final answer, take the unsimplified form. So for cosecant, we have a negative radical 7 over 4. If you flip that, it's going to be negative 4 over radical 7. And we need to rationalize this, so we're going to multiply both the numerator and denominator by radical 7, and that's going to be negative 4 radical 7 over 7. And then finally, it says find the cotangent of theta, which I'll do on the side. So I know my tangent of theta before I simplify it is 3 over negative radical 7. If I flip that, it'll be negative radical 7 over 3, and that will be the cotangent. And this last example, we will do in class.